Hey there, students. Today we're diving into the fascinating world of physics with a focus on Newton's second law of motion. First, let's give a quick shout out to Sir Isaac Newton. Born in 1643, Newton was a revolutionary scientist whose work laid the foundation for classical mechanics. Now onto the juicy stuff, Newton's second law. According to Newton's second law, the force acting on an object is equal to the mass of that object multiplied by its acceleration. Simply put, force equals mass times acceleration, or F equals sine mag. This law helps us understand how objects move and interact when forces are applied, but enough theory. Let's get our hands dirty with some mind-blowing experiments to see this law in action. Ready? Let's go. First up, place a small cart on a smooth, flat surface. Attach a string to the cart and run it over a pulley at the edge of the table. Hang a weight at the end of the string. When you release the weight, it falls, pulling the cart along the table. Notice how the cart accelerates more when you add more weight. That's Newton's second law in action. Increasing the force results in greater acceleration. For our next experiment, you'll need a balloon, string, and a straw. Thread the string through the straw and tape one end of the string to a wall. Inflate the balloon but don't tie it off, just pinch it shut. Tape the balloon to the straw and release it. Watch how the balloon rockets along the string. The force of the escaping air propels the balloon forward, demonstrating how force and acceleration are related. Here's a simple yet effective demo. Drop two objects of different masses from the same height. Despite their different weights, they hit the ground at the same time, provided air resistance is negligible. This shows that the acceleration due to gravity is constant, regardless of mass. But if you apply a different force to each object, they'll accelerate at different rates, just as Newton's second law predicts. Grab a friend for this one. Stand on a skateboard or a smooth surface with wheels. Hold onto a rope and have your friend pull you. The harder they pull, the faster you accelerate. This is a fun and physical way to feel Newton's second law in action. The force your friend applies to the rope accelerates you, showing the direct relationship between force and acceleration. There you have it, folks. Newton's second law of motion explained with some super cool experiments. Remember, this law is fundamental to understanding how objects move and interact in our world. So next time you're pushing a shopping cart or riding a bike, think about how Newton's second law is at play. If you enjoyed these experiments, give this video a thumbs up and subscribe for more awesome science content. And as always, stay curious and keep experimenting. Catch you in the next video.